So let's start with the next section, students. This section contains two matrix match the column types questions. So the entries in column 1 may have one or more options corresponding to entries in column 2. Okay. So let's start with question number 36. So we have to match the compounds given in column 1 to the properties given in column 2. So if you look at the A option now, so the species given in option A are stereoisomers to each other, but they are diastereomers as the configuration at only one chiral carbon is different. Okay, so this is the cis and this is the trans species. So they are diastereomers. So A will be matched with P. They are not enantiomers. They are stereoisomers, yes. A will also be matched with R, and A will be matched with S as well. They are cis trans isomers. Okay. Looking at option B now. So if you look at option B, we have the OH at the wedge position and the Cl at the dash position. And if you look at the second structure, we have OH at the dash position and Cl at the wedge position. So if we flip this structure on the plane of paper, we are going to generate the structure which is given on the left. So we can see that these structures are identical. All you have to do is just flip any of these two structures to get the other structure. So these are identical. So option B will be matched with T. They are identical. Let us look at option C now. In option C, we have two structures, both of which are isomers of 1, 2, 3 trihydroxycyclopropane, in which two OH groups are in the same direction while one of them is in the different direction in both the structures. The first structure contains two OH groups at the wedge direction, whereas in the second structure the two OH groups are present in the dash position. So students, they might be identical or they might be enantiomeric. So we have to make some transformations to figure that out. So let us first try and rotate this triangle. So if we rotate this triangle by 120 degree, we'll have this structure. The orientations of the OH groups is not going to change. We've just rotated it in the plane of paper. So we get this structure. And now if we flip this, structure, we get the compound given on the left. That is, the groups present in the bottom positions will be now wedged, whereas the group present on the wedge position will now be dashed. So we can clearly see that this is the structure given on the left. So students, these two species are also again identical. So C will also be matched with T again. Now if you look at the last option, which is D, we can see that these two structures differ in their configuration at only one chiral carbon. So they have to be diastereomers. The compound on the left is a meso compound, whereas the compound on the right is not a meso compound. Okay. So the structures are diastereomers. The structures are not enantiomers. The structures are stereoisomers. So R will be a match. These are not cis trans isomers, and these are also not identical. So the correct matching for species given in option D will be with option P and option R. So students, this is the correct match for question number 36. Let us look at question number 37 now. So column 1 contains reactions while column 2 contains the intermediate or type of reaction or major product formed in column 1. So let's try and solve the reaction sequence first. We can match the properties later. So in the first step, benzene is allowed to undergo nitration. So it will give us nitrobenzene. So nitrobenzene is now allowed to undergo reduction using tin HCl. So it will convert it into aniline. It is further subjected to acetylation, in which the lone pairs of nitrogen will attack the carbonyl carbon and make the Cl group leave. So we'll have NHCOCH3. Okay, so this is our compound L. Now when this compound L is subjected to chlorination, we'll have a para substituted product as major because of the steric hindrance created by the bulky group. and then after hydrolysis it is going to regenerate the NH2 group which was present. So when we hydrolyze this, we get parachloroaniline. So this is our structure M. Now this M is allowed to undergo diazotization with HNO2, and it is further allowed to react with phenol in the presence of basic medium. It is a coupling reaction. So in the first step, it will be converted into PHN2Cl with a chlorine at the para position, and then it is allowed to undergo coupling with phenol in basic medium. So the coupling will take place at the para position. We'll have OH, N double bond N, and we'll have PHCl. So this is our structure N. Now in the fourth reaction, the species M is further allowed to undergo diazotization followed by the chlorination. Okay, so we can have this reaction sequence somewhere around here. So M, which was parachloroaniline, is first converted into PHN2Cl with chlorine at the para position, and it is further subjected to chlorination using Cu2Cl2. So we have 1,4 dichlorobenzene. So this is our product O. Okay. So let us now look at the options in the reaction given in option A. So we have benzene converting into nitrobenzene. So this is an electrophilic aromatic substitution reaction in which there is a generation of carbocation. So A will be matched with P. The reaction is aromatic substitution reaction, as we had seen that. So it will also be matched with Q. Product give bad smelling substance. It is incorrect. It will be matched to an amine and a primary amine to be more precise. So this statement is also will not be matched with option A. Let's look at the next option. Dipole moment of product is 0. This will also not be a match. The dipole moment is not 0. The product L has some dipole moment. So option A will be matched with option T. The dipole moment of major product is non-zero. So we have P, Q and T as the correct match for option A. Let us look at the next option in which L is converting into M. So we have the formation of parachloroaniline in this reaction. So there is a generation of carbocation during the electrophilic substitution reaction in the first step. So P will be a match. It is an aromatic substitution reaction. Cl is replacing hydrogen. It will be matched with Q as well. Now we have a primary amine now in the form of M. We have aniline. It will give us bad smelling substance with CHCl3KOH. So we'll have a match with R as well. And we'll have a match with T as the dipole moment of the product is non-zero. So B will be matched with P, Q, R and T. Let us look at option C now. M is first converted into diazonium salt and it is allowed to undergo coupling with phenol in the presence of basic medium. So we have the generation of a carbocation. It is also an electrophilic substitution reaction. We'll have an electrophilic aromatic substitution reaction. So Q will also be a match. It will not be matched with R as primary amine is not formed. It will be matched with T as the dipole moment of the product is non-zero. So the correct matching for option C is P, Q and T as well. Same as option A. Now if we look at the D option in which M is converted into O. So we have parachloroaniline converting into para-dichlorobenzene. In this case, there is no formation of carbocation. So P will not be a match. We have aromatic substitution reaction, yes. The N2 group is replaced by Cl. So we have aromatic substitution on the ring. The product give bad smelling substance. This will not be a match. And the dipole moment of the major product is 0 in this case as we have para-dichlorobenzene. So the correct matching for option D will be Q and S only. So students, this is the correct matching for question number 37.